Hello friends, Mr. Burrell here. In this video here, we are going to review solving linear equations. In this particular video in Math 3, this is something that you should already know how to do. You've done it a long time. You should know how to solve linear equations. But in order to do all the rest of the stuff that we're going to do in Math 3, having these skills down pat and really having them solidified and sharpened and ready to go is going to be really helpful. So we're going to review solving a variety of different kinds of linear equations, okay? Here's a little funny for you to brighten your day. As far as solving linear equations goes, you can pause and look at that for a sec. But by the end of this lesson, hopefully you feel comfortable solving linear equations and inequalities, okay? And we'll talk about some terms and definitions and things to remember in terms of both of those things, okay? So some definitions. Again, all these are things you should already know, but will be handy to review. A reminder that a variable is just a symbol that acts as a placeholder for some quantity that I don't know that could change, okay? A lot of times we deal with x and y as example variables, okay? But that's all a variable is, a symbol, usually a letter that acts as a placeholder for something that could change. An expression is a number, a variable, or a combination of numbers and variables, and operation symbols. So like addition, subtraction, multiplication, division. So something like 3x plus 7, or, that's a 7, 1/2 x times 3x plus 5, or something like that. That is an expression. When I have numbers, variables, parentheses, addition, subtraction, multiplication, division all mixed together. Whereas an equation is a statement where two math expressions are equal to each other. So if I had like 3x plus 7 equals 1/2 x times 3x plus 5, I'm just making these up on the fly here, that would be an equation because we're dealing with an equal sign. Two expressions are equal to each other, okay? An inequality is similar to an equation, but instead of an equality relationship where two expressions are equal to each other, a statement of an order relationship between two expressions is what we're talking about. So instead of using an equal sign, I could have like a greater than or equal to sign, or a less than sign, any one of these inequality symbols expressing not equality, but that one quantity is bigger or smaller than the other, okay? When I'm talking about the word simplify, that means to make something simpler. So if I gave you this, for example, 1/2 x times 3x plus 5, and I asked you to simplify that, you would probably multiply this together so I could condense that into as few terms as possible. That's what to make simpler means. Or if I had like 2/4 and I asked you to simplify 2/4, you would probably say that simplifies to 1/2 because 2/4 can be simplified as a fraction 1/2. Whereas to solve an equation is to find an answer for a problem. So if I have this equation and I ask you to solve that equation, that typically means I want you to find what x is going to be equal to that's going to satisfy this equality. What do I put in for x that makes the left side equal to the right side? Okay, that's really what we're going to do in this lesson, is to talk about how do I solve these different kinds of equations, okay? So really, we're just going to go through a handful of examples, make sure we feel comfortable solving some simpler linear equations up to some more complex ones. Okay, so we'll just go through these. It would be advantageous for you to pause before I do each of these examples. Try to do it on your own. Make sure you feel comfortable, okay? So example number 1 here says 4x plus 2 equals 10 minus x, okay? So if I'm asking you to solve for x, first of all, I need to get all the x terms on the same side of the equation and all the rest of the terms on the other side of the equation. So I'm going to go ahead and add this x to this side. That's the opposite of subtraction, is addition. So that's going to leave me with 5x plus 2 equals 10. I want to get rid of this 2, so I'm going to, since 2 is being added, I'm going to use the inverse operation and subtract 2 to the other side, which is going to give me 5x equals 8. Okay? So now I have 5 times x equals 8. In order to get x by itself, I'm going to have to undo that multiplication by doing division. So I'm going to divide everything on both sides by 5. And my answer is going to be x equals 8/5. And sometimes we get upset when we have answers that are fractions or decimals. Don't be upset. That's going to be totally okay. Totally okay to get fractions and decimals in my answers. Okay? Example number 2 says -9 plus 3x equals -x plus 2x minus 4. So a couple extra things going on. First of all, I have x's in multiple places rather than just one set of x's on the left and one set of x's on the right. So again, let's get all the x's on the same side of the equal sign. It does not matter which side I put all the x terms, so I'm going to go ahead and, first of all, combine these like terms together. It's going to give me negative 9 plus 3x equals negative 1x plus 2x is going to give me just a positive 1x minus 4. So I'm going to go ahead and subtract this x to this side, giving me negative 9 plus 2x equals negative 4. Then I'm going to add this 9 over to this side, giving me 2x equals negative 4 plus 9 is a positive 5. Then again, since 2 is being multiplied by x, in order to undo multiplication, I divide, giving me x equals 5 halves, or 2.5 if you're a decimal person. Okay, that's my final answer there. Again, pretty straightforward examples. Let's look at a couple more. These ones have a couple extra things going on. Note here I have some parentheses that I'm dealing with, okay? So in this particular problem, what I would do first is I would simplify this expression right here, where I have negative 2 multiplied by something in parentheses, so I can get rid of the parentheses. So I'm going to go ahead and multiply this negative 2 into the parentheses. So I'm going to get negative 4, negative 2 times x is negative 2x. Negative 2 times negative 1 is a positive 2, and that equals 4x plus 6. Okay. So now this looks really similar to example number 2. So I'm going to go ahead and combine these like terms. Again, make this a little bit simpler. Negative 4 plus 2 is negative 2. Minus 2x equals 4x plus 6. Okay. Now, again, this looks very much like example number 1. I'm going to get all the x's on the same side, everything else on the other side. So I'm going to go ahead and subtract 4x over to this side. Notice in all these problems, I've been moving all the x's over to the left-hand side. Does not matter, though. Do whatever you want. Negative 2x minus 4x is negative 6x. So I have negative 2 minus 6x equals 6. I'm going to go ahead and add 2 to the other side, which is going to give me negative 6x equals 8. I'm going to divide by negative 6 on both sides. So that gives me x equals negative 8/6. Or if I were to simplify that fraction, negative 4/3. Okay? So that's that example. Let's take a look at example number 4. This one is going to be a little bit more involved. There's a couple of things I could do in this problem to help me make this a little bit easier on myself. I have some fractions here. Okay? So first thing that I would recommend doing, notice that in this whole problem, these two fractions that I have are halves. So I have 21 halves and 3 halves. I'm dividing by 2. So let me go ahead and start. This is one way I could go about solving this problem. I'm going to go ahead and start by multiplying this entire equation by 2. If I multiply 21 halves by 2, I'm just going to be left with 21. If I multiply 2x by 2, I'm going to get negative 4x. And if I multiply 3 halves by 2, I'm going to be left with 3x. Look how much easier this problem is going to be for me to solve. I'm going to go ahead and add 4x to this side, giving me 21 equals 7x. And then I'm going to divide by 7 on both sides, giving me x equals 3. Okay? On that time, I moved all the x's to the right side. Okay? Another thing you could have done in this problem is you could have made all the fractions in this entire equation have a common denominator. So I could rewrite this expression as 21 halves. Negative 2x, if I were to rewrite negative 2 with a denominator of 2, I would multiply the top and bottom, considering this is negative 2 over 1, by 2, which would be rewritten as negative 4 halves x. Okay, negative 4 halves is the same as negative 2, equals 3 halves x. And then I could go about solving this problem as I did before, but now that all of the fractions have common denominators, I can do addition and subtraction of these fractions much easier now that they have common denominators. So you could finish solving this way, add 4 halves x to this side, which would give me 21 halves equals 7 halves x. And then you could solve from there. Like, for example, you could multiply by 2/7 on both sides. Sometimes you call that multiplying by the reciprocal. That would give you x equals 21 halves times 2/7. Well, the 2's cancel out, and 21 divided by 7 is 3. I end up with the same answer. Just an example of 2 different ways you could go about solving that problem. Okay? Let's see here. Let me scroll. All right, let's take a look at these two, examples 5 and 6. This one right here, example number 5, is another example dealing with fractions. Sometimes we're afraid of dealing with fractions because there's a lot of stuff going on. In this particular problem, these two fractions are fifths. They have a denominator of 5. This fraction has a denominator of 10. Okay? So if I go about this problem the same way, the first way I did example number 4, I would want to multiply this entire equation by something so that all the fractions went away. Okay? Well, if I multiplied everything by 5, note that that would get rid of these fractions, and then this negative 3 would turn into a 15. But 5 times 1/10 is just 5/10. That's still going to give me a fraction. So instead of multiplying by 5, I'm going to multiply by 10. Because if I multiply by 10, I'm going to get rid of both of these fractions and this fraction. Let me show you. If I multiply by 10, 4 fifths times 10 is going to be 40 fifths, which 40 divided by 5 is 8. Okay? If I multiply 2 fifths times 10, I'm going to get 20 fifths, which is negative 4x. 20 divided by 5 is 4. Equals 1/10 times 10 is just 1x. And then negative 3 times 10 is negative 30. See how much easier this problem is to solve now that I don't have any fractions. Okay? So I'm going to go ahead and I'm going to mix it up a little bit. I'm going to go ahead and add 4x onto this side, which is going to give me 8 equals 5x minus 30. And then I'm going to go ahead and add 30 to this side, which is going to give me 38 equals 5x. I'm going to divide by 5 on both sides to give me x equals 38 fifths. Okay? So another kind of example with some of those fractions and how to take care of them. Okay? The last problem I want to do is an inequality problem. Okay? So I have 44 is less than negative 6 times 2x minus 1. Okay? Couple things I could do. I'm going to solve it one way on this side of the line and then one way on the other side of the line. So first thing I could do is I could distribute the negative 6. That would give me 44 is less than negative 12x, because negative 6 times 2x is negative 12x. Negative 6 times negative 1 is a positive 6. Okay? Then I'm going to go ahead and subtract 6 to the other side, which gives me 44 minus 6 is 38 is less than negative 12x. Then I'm going to divide by negative 12. Okay? Note, something to pay attention to when I'm dealing with inequalities is whenever I divide by a negative number, this inequality symbol is going to change direction. So I'm going to be left with x is less than negative 38 over 12. I could simplify that fraction if I wanted to. I think that's negative 19 over 6. But x is less than negative 19 sixths. Or you could flip it around. X is less than negative 19 sixths. Okay? From the very beginning, note that another thing I could do, since negative 6 is multiplied by this whole parentheses, I could divide both sides by negative 6 right from the get-go. Okay? Which would leave me with 44 over negative 6, which simplifies to negative 22 thirds. Or I could just leave it as 44 6, doesn't matter. Since I divided by a negative, this inequality symbol would switch directions. And that would be equal to 2x minus 1. Okay? And then I would have to add 1, divide by 2, and you'd have to do some extra math, get some common denominators in order to make that work. You would end up with the same final answer, negative 19 sixths. In my opinion, the first way that I solved that problem is probably the easiest, but I just wanted to show you that there are several ways, a couple different ways that you could go about solving each of these equations. Okay? We're going to skip this part. So that's really it. Obviously, that's not a summative view of every single time of linear equation / inequality you could encounter, but that's a good chunk of the different types you might see. So hopefully you feel a little bit more comfortable solving a linear equation / linear equality. I hope that was helpful. Please let me know if you have any questions.